You ever do an experiment where you have a list of data, and maybe we're just going to call our variable x, and we have, say, 5. Well, what if you have more than one piece of data? You're going to call that x1. And then you might say, well, we need an x2, say 7. You need an x3, that might be 9, and an x4. I think you get the idea. Okay? Well, these are separate variables. And if you had a data table from a lab, you would really just say that this is just one element of your list. And we're going to put these things in parentheses here. These little numbers are an index to tell us which piece of data we're looking at. This is an array in computers. I could come down here and say print x sub 3. Let's see what we get. Yeah, we got 9. That's the third value in our data table. Well, we can try making shapes, and it might be an interesting example to see how arrays can work. Okay, I've set up a graphic screen, and now I'm going to create an array, and let's say that's x is 0. And now I'm going to also have another array for y. Okay, as we can see, we have 3 sets of data. I'm going to say for I equals 1, 2, 3. Let's just plot this. As we can see, we're going to be plotting each x and y pair. I is going to go from 1 to 3. And we can see that we have our 3 data points. Would it be possible to connect these things? Well, we could try it like this. We could say if I equals 1, then we'll plot the first data point. And then we'll draw a line to the next one. Hey, isn't that nice? What else could we do with something like this? Well, we could scale it. I'll write scale. In the x direction will be 2. Scaling in the y direction, we could do them separately, will be 3. And now I'll just put the scaling factor in front of each coordinate. Oh yeah, much larger. So that's scaling. I can also do something called translation. Translation just means to move it somewhere around on the screen. So what if I wanted to move it to the left? I might put in a -3 and a translation in the y of -2. There's our translation factors coming in. And now we've seen the shape has been moved over. I can have a little fun with this and make the translation factor change. For tx equals -10 to 10, step 0.5. Next, tx. Now I'm going to put the sleep command in here. Yeah, it's kind of what you'd expect, right? And we could do something like this for j equals 1 to 100. We could say tx equals, say, 20 times RND1 minus 10. Ty equals 20 times RND1 minus 10. And we can randomly place our shape all over the screen. Okay, so we've got our object plotted on the screen, scaled, translated. Now, what if I wanted to rotate it? That requires a little bit of math. Okay, let's see what we have here. We've got pi, and then we're going to convert 20 degrees into radians. And then we're going to run through the array and rotate each point in the array, storing it back in the array. These are sine and cosine functions, and you can look up this rotation technique in a math book. So now we've got the data points all rotated, and then we're going to go down here and translate and scale them and plot them. Now you might notice that this is not a 90-degree angle in here. And that's because the aspect ratio when we go to full screen isn't 0.75 anymore. It's 1. Let's try that again. Okay, that looks a lot better. So once I define the angle and it has been rotated a little bit, we'll say for J equals 1 to 10. Next, J. Okay, so this is a good example of how we can use an array to store in data, to plot on the screen to make a shape, and then have it rotated, and then scaled and translated on the screen. Now, if I wanted to use a larger array, more than 10 elements, I'm going to have to tell the computer ahead of time. And it's called dimensioning the array. And that command is dim x sub, say maybe I needed 100 data points. And I can say dim y 100. Well, that's what you'd have to do if we had more than just a few points. You're more than 10, you're going to need to do that to reserve the memory for use as the array.